Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 27th April 2023. The problem statement for today is easy task. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it is said, given a string S whose length is n and array queries of length q where each elements of queries is either of type 1 query or type 2 query, which is explained ahead. There are two types of query. Query type 1, it consists of three elements, that is one index location, that is index and char. So one denotes that this is type 1 query. In this query, you have to change the character at index ind in S to character char. Data type of int, that means index and char, is string in input. Okay, so this was type 1 query. Type 2 query, this again consists of four elements, that is 2, left, right, k. 2 indicates that this is type 2 query. In this query, you have to return the kth lexicographically largest character in the substring of S. It is kth largest in the sorted order, not the kth distinct character. So starting from index left and ending at index right, both inclusive, where both left and right are inclusive. Data type of left, right, k is string in input. You have to perform each query in same order as given in queries and return an array, that is response or result, such that the array contains the answer of each type 2 query in the same order as it appeared in the queries. Okay, and in note it is given that this is zero based indexing. Okay, so here the problem statement requires us to perform two types of query on the string, that means on a given string. So one that involves changing a character at a given index in the string, and other involves finding kth lexicographically largest character in the substring of the string, which falls in the range of left and right. We need to perform the queries in the order they appear in the input and return the answer to type 2 queries in the same order. Okay, so I hope the problem statement is clear. So let's go through the given examples here. So the first example says, here the n is equal to 4, given string is AB, and here the queries are, the number of queries is 2 here. Okay, so what was n here? So n was the length of the string. Okay, so here the 4 is the length of the string, q is the length of the queries. So here the output is d. So the first query is of type 1 because it is indicated with 1 here. So after changing the character at index 2, so here the index location is given as 2. So we have to change the whatever character is there in this string at index location 2 to the character which is given in the first query, which is d here. So after changing the character at index 2 to d, it becomes ABDB. So this A will be replaced with D. So this was the first query. Okay, so after first query we got this response. So now the second query is of type 2, in which first, where the k is equal to 1, if we look at this one, here the type 2 query, k is the last element in this array. So here we can see k is 1. Okay, so in which the k, where k is equal to 1, lexicographically largest character is d in the substring BDB, that is 1 to 3. So we return the result of type 2 query, that is d. Okay, so this was the first example. When we look at the second example, so here it is saying that length of the string is 3. The string contains character A, and here it is given 3 queries. So here the output, it is saying it is C. So in explanation it is given, after applying first 2 queries, S becomes AEC. So here, if you look at the first two queries, it is of type 1, where in first query, the character at the first index has to be replaced with E, and character at the second index has to be replaced with C. So after these two queries, the string will become AEC. Now for the last query, which is of type 2, the second largest character in the substring S, starting from index location 1 and ending at 2, is C. Okay, so starting from this one and ending at 2. So here the second largest character. So here the character will be C and E. So lexicographically the second largest character, because here 2 is given, that character is C, so C is returned. Okay, so I hope both the examples and the problem statement is clear to you. So to solve this problem, we can iterate over the queries array to perform the corresponding operations based on the type of query. For each type 1 query, we can simply update the character at the given index in the string. For each type 2 queries, we can extract the character of the substring from the string, sort it lexicographically, and return the kth largest character in the sorted substring. Okay, so we'll follow this approach. That means instead of sorting it, here we will be counting the frequency of each occurrence of each character, and then we will be iterating it in the reverse order, so that in sorting it takes somewhat more time. So in this way, we can just simply iterate the complete array once in the given range of left and right, and we can create the frequency map, and we can iterate in the reverse order, so that we can get the lexicographically the largest element at whatever position it is required, or it is asked in the problem statement. Okay, so here we won't be performing any sorting operation. So so with this approach only, let's move to this Java editor. I have prepared a solution. See, whatever the steps are there in the problem statement, we are doing that. We are doing those steps straightforward. Okay, so here in this editor, you can see the class query is given here. It consists of 4 characters, that is type A, B, and C. All are type of string, and this is one constructor to initialize the query class. Okay, so that query class is again here used in the problem statement. That means as a input method. For this easy task method, these are the 4 types of inputs which is accepting in this one, where n string s, query number of queries is q, and the query array. Okay, so so I'll explain it line by line. I have even tried giving comments against each line, so that it becomes easy in understanding. So as I said, all the steps in this problem, in this solution, is exactly the same which is asked in the problem statement. We've not taken any other logic or nothing, deviation, no edge case, nothing like that. So whatever it has been there in the sequentially, we have done that way. So the solution starts by creating a character array from the input string using toChar array method of the string class. It also initializes array list to store the result of type 2 queries. So we have initialized these 2 arrays here. Okay. After that, this code iterates over the queries array for using a for loop. For each query, it checks the type of the query using the type field of the query object. Here we are getting the type 1, and then we are checking if it is type 1. If the type equals to 1, then what all operations we need to perform? We need to replace the character which is present at index given index with the character given as the third element of that query. So what we are doing here, we are extracting that value at this object which is there at A8 location. So that will give the index position, because here you can see this one. If you look at the constructor, so the first one is type, this is A and this is B, and in case of second query, we have extra C here. So for first query, only type and A and B is applicable. Okay, and since everything is given in the form of string, we are using integer.parseInt to convert it into string, integer. So here with this one, we are getting the index position index position of in the string where the character has to be replaced. So we get the index position. So now at this now after that we are getting the character which is located at this one, which is located at yeah, now we are getting the character that has to be replaced in the index position that we have computed in the previous step. So that particular value, character value, we are getting from current query dot b, because if you can see again in the first, in the input object, this is type, this is a and this is b. So whatever is there at b, so if you look at this example, then we'll get d here. So that character we are getting. Now what we are doing, we are replacing that one. That means in character array, we are replacing the character at that index with the character which we have got in this step using current query dot b. And here we are doing caret at 0, because again, and even this character is given in the form of string, and since it contains only one character there, it will contain, but just to get it in the character format, we are just performing caret operation on the string method. Okay, so this was type 1 query. If it is not the case, that means if the type is not equal to 1, then it will be type 2 query. So here we need to perform here we need to find the kth element, kth largest element lexicographically. Okay, so here in this type 2 query, the solution performs a type 2 query by finding the kth lexicographically largest element, largest character in the given substring of the string. To do this, it first extract the character from the character array using the left and the right indices specified in the query object. It then creates a frequency array to count the occurrence of each character in the substring. This is done by iterating over the substring and incrementing the frequency of the corresponding character in the character array. Okay, so here again we are getting all the parameters here, left, right and k, and we are converting it to integer, and after that we are creating a frequency array to count the occurrence of each frequency. Okay, once this is done, then then we are left with the last task, that is to find the kth largest element in the substring of s. So here we start the code starts by initializing a count variable to 0, which will be used to keep track of the number of characters seen so far. It then iterates over the frequency array in reverse order, starting from the highest possible character value that can be z or 25, and moving in the backward direction to a or 0. So if you start from 0, and if 0 is indicating to a, and we know 26 characters are there in alphabets, so the largest one will be present at location 25th, so that will be z. Then for each character in the frequency array, the code counts the code adds the count of that character to the running total count. If the count is greater than or equal to k, it means that the kth largest character has been found. Okay, so if this condition becomes true, that means we have to find the kth largest one. But after adding the frequency, if counts become greater than or equal to k, so that means whatever we were looking for, that we have got. Okay, in this case the code adds the corresponding character to the result array and breaks out of the loop. So to this one we are converting it, since here j was the integer, but we need to find the kth character there, that means the character which is occurring at the kth position, that means kth largest position. So for converting it to character, we are this typecasting is done here. So this, when you add this one to character a, the integer variable, it will calculate the ASCII value in the character format and it will add to the resultant, and we break out from the loop. Okay, so once we come out of this loop, then we simply return whatever we have added in the resultant array, which is of array list of character type. Okay, so that's it. So this was the coding part of it. Let's try compiling this code. As I said, that whatever operations that has been defined in the problem statement, we did in both the scenario where the type is equal to 1 or 2, we just did that. we extracted those value, and we in the first query we just replace that character, we replace that given character at a particular index in the string, and when it is type 2, then again we extracted those characters, and in the given range of left and right we found the frequency of all the characters there. Then we start the iteration from the last one, because we had to find the kth largest lexicographically, and not the distinct one. So we start from the last one, and whatever is the count required there, that means whatever the frequency given there, that means the kth largest. So what is the value of k? So we just counted the frequency of each characters there. So this is equivalent to sorting it in reverse order and just counting it up to k. So instead of sorting, we've just counted the frequency and keep on adding that count in the running count, and wherever the count increases, that means this condition becomes true, that means count is greater than or equal to k, then we add that particular element in the resultant array or resultant array list, and we break out from the loop. So here we can see we have got correct output for the given input. Let's try submitting this solution. So here we can see it has covered all the test cases, so this problem has been solved successfully. So talking about the time complexity of this approach, it is in the order of big O of Qn, where Q is the number of queries and N is the length of the string. This is because we iterate over the queries array once and perform a linear scan of substring for each type 2 query. The space complexity of this approach is big O of N, since we store the character of the character array and the resultant array list as an array list of characters. Okay. Okay, so I hope this explanation is clear to you. So this was the Java solution. Even I have prepared the C++ solution of it. So let me move to this editor and let me copy the C++ code here. Here again the steps are completely same. Here also yeah, so here also we are creating an character array which is starting from this one. Create a character vector from the input string. That means yeah, whatever is that given in the problem statement, we are creating an array out of that, and we are creating a vector to store the result of type 2 queries. Then after that we perform again the same thing. We check whether that it is the type is type 1 or type 2, and based on that we perform the respective operations. So the logic is completely same, only the syntactical difference, like for converting the string to integer we use stoi here, stoi function, that means string to integer, and in Java we use string integer.parseInt. So those all differences are there. Apart from that everything is same. There we deal with arrays and here we deal with vector. Okay, apart from that the logic is completely same. Let's try compiling this code. So here even for with this C++ solution we have got correct output. Let's try submitting this solution. So here we can see even in C++ all the test cases is covered. So this problem has been solved successfully in both Java and C++ language. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.